Hi, so this particular video focuses on just an introduction to heat, maybe a little bit of a review of heat, and also touches on one of the methods of heat transfer. This is chapter 13 in the textbook that we're using this semester. All right, so the first question I have is, well, what is heat? And it turns out that heat is a measure of the internal energy of an object. So the more heat an object contains, the more the atoms that are composing that object will vibrate. The higher the energy is, the more violently they will shake back and forth. And if an object doesn't have much internal energy, then maybe it'll just get small vibrations, something like this. Heat and temperature are not the same. Sorry, heat and temperature are not the same. Heat is again is energy, and temperature is not. So just like the energy that we learned about last semester, kinetic energy, gravitational potential energy, so on and so forth, heat is just another form of energy. All right. So there are three methods by which heat transfer occur. These are convection, conduction, and radiation. We'll go through each one of those in some detail. This video will just cover convection. All right, so in convection, what we have is we've got a fluid that has temperature differences throughout the fluid. And then the hotter fluid is going to rise, displacing cooler fluid. And that cooler fluid is going to sink. And instead of this being just a straight up down kind of motion, which would be kind of hard to pull off, honestly, stuff going up and down in the same location, this ends up being kind of like a circular kind of motion almost, which is what we can see in this pot of water there. The water directly above the burner gets hot, rises, shoves some of the water over, the cooler water over to the side, that then sinks, and so on and so forth. So we get kind of a fluid motion, I guess, kind of like a cyclical motion almost. All right, so examples of this are things like maybe a baseboard heater in your apartments, where the air next to the baseboard heater will get hot, will rise, will displace the air above it, so shove it to the side. And then that air will end up falling down, and then we basically just get a whole kind of circular motion of the air again. Same thing in your refrigerator, except now we're taking heat out of the refrigerator. And so you can see the cooling coils are up at the top of the refrigerator, whereas with the heater, they're down at the bottom of the room. So your cooling coils there are going to cause are going to take heat out of the air that's next to the cooling coils. That air is going to sink because it's more dense than the hot air. It's going to displace the air beneath it, shove it to the side, and then we get this kind of circular motion again. So we've got bulk motion of a fluid. All right, so we could have warm air rising from the ground, and this creates basically kind of like an updraft, and birds can glide on these, which is kind of cool. In addition to these examples of natural convection that we've had, we can also have something called forced convection. This is where we've got a fluid that is we're cycling through some apparatus. The best example of this is your radiator. So you've got fluid going by your engine. That fluid gets hot next to your engine, and then it's forced towards your radiator where it gets cooled down again, and then cycles back through to your engine, and so on and so forth. And so this is how we cool the engine to keep it from overheating. Forced convection. All right. So I've got a little question here. It says, imagine that you're at a lake during the summertime, and it's kind of a warm day, but you're feeling a nice cool breeze blowing into your face from the direction of the lake. We're asked which of the following best explains this breeze. Well, is it that air naturally flows from cooler locations to warmer locations? Is it that the lake must be west of the land because winds typically blow from the west? Is it that we've got warm air rising above the land and cool air moves downwards, appearing to come from the direction of the lake, but is really from above the land? Or is it that we've got warm air rising from above the land and that warm air is replaced by the air blowing in from the lake? So think about that for just a moment. Pause the video. Okay, it's actually choice D. The warm air rises up from above the lake. Something's got to take its place. Yeah, so cool air rushes in to take its place, and we end up getting this kind of circular motion again with the air cycling through. All right, that does it for convection. There's actually no equations attached to convection as far as a Physics 1 or Physics 2 class goes, because the equations for convection are actually quite complex and aren't something that's really appropriate at this level.